Hi, my name is Rosa.
And I am Caro.
And we are going to talk about the tools that enables to perform an early design analysis and how to use the tickle scripts to do an interactive and traversal analysis in a design.
We will cover a quick introduction and demonstrate the RTL Analyzer GUI and how you can fully visualize all design intent with the schematic viewer.
Then we will show the new advanced analysis and report tools like sweep hints.
And finally, we will show how the new RTL Analyzer tools can perform an interactive traversal analysis with tickle commands and GUI. Why we developed this product? We know that with increasing size and complexity of FPGA designs and the growing IP design reuse, FPGA design compilation is no longer a push-button flow.
Users demand an early way to validate the integrity and the correctness of their entire design during the process, and not until the end, which makes it more efficient. As designs are becoming larger and more complex, they are requiring faster design flows and frequent iterations during the process, as well as the quest to reduce the time to market. Intel has been developing early design analysis with the following objectives: provide a comprehensive early visualization of various user intents, like IPs, RTL, design constraints, and others. Advance analysis tasks and reports to surface any potential design issue and accelerate flow convergence. Design traversal tools and APIs for interactive analysis and custom analysis tasks.
The RTL Analyzer provides you four different views of your design, fast and early in the flow. It will help you enter, understand, and perfect your designs in Quartus. Usually, analysis and synthesis is presented as one step. An RTL viewer takes a while to process and load. Now, the new analysis and elaboration have access to different views of the RTL. By clicking on the first magnifier, you will have access to debug a version of the RTL which is unmodified. By clicking on the second magnifier, you will see a version of the RTL with system-level debug inserted into the design. So if you are using Signal tab, you can see the project's wire connected to the Signal tab instance. In the third magnifier, the RTL will contain all SDC constraints in the design. And finally, fourth magnifier will show you the RTL with all unnecessary logic removed from the design.
RTL Analyzer GUI. How can you fully visualize all design intent? The GUI consists of a schematic viewer. Design elements such as modules, instances, ports, and so on are represented in the schematic viewer. The viewer reacts and updates to focus on different objects as you navigate through the netlist. A hierarchy browser. The design hierarchy browser renders the design netlist. The core elements are modules, instances, ports, instance ports, and nets. A properties viewer provides information about the SDC assignments and constraints attached to the object selected in the hierarchy browser. It can be cross-referenced to the assignment definition in the source file. A tickle console works in two ways. While you are working in the GUI, it displays the relevant tickle commands and shows the issues. And as you type tickle commands, the GUI responds accordingly. And finally, a powerful object finder. You can access it by clicking Edit menu and then Find. It helps you locate an object in the design netlist. You can refine your search based on the object type: instance, instance bus, port, instance port, net, and net bus. It filters in several criteria. For example, name, module name, leaf, source file, source line, and so on. The object finder focuses more on the point-to-point relationship of a particular net.
With the RTL Analyzer GUI, you can also perform cross-probing. If you right-click on an object on the schematic and select Locate Node, Locate in Design File, The RTL analyzer will show you the source code of the object where it was defined, and it will be highlighted of the object pane. You will also see the properties of this object in Property Panel. At the same time, the Tcl console will automatically present you the selection commands of the highlighted objects.
Another new feature is the Sweep Hints viewer. You can access to it from the RTL Analyzer menu by selecting Tools, View, and then Sweep Hints. It allows you to understand why synthesis removes certain logic in your design. With this tool, you will be able to root cause why objects were swept by synthesis. This database also tracks relationship between the removed objects. The swept objects are hierarchically arranged so that you can query, filter, and find regions of interest quickly. The last new feature is the Object Set Console panel. It displays our currently selected, highlighted, or colored nodes in the schematic viewer. To launch the Object Set Console dialog box, navigate to the View menu in the RTL Analyzer interface and click Object Set Console.
You can make your own Tcl scripts and add them to your project. In this case, we have this script that shows us all the cables that have a fanout greater than 15. First, we put the command of the previous script in the Tcl command line to do the process. The RTL analyzer will take the filter that we put in the script, and as you can see, it puts in red the matched ones. And you can customize the search according to your needs. In this video, we talk about the benefits of using this new feature. We learn about the different tools that the RTL analyzer offers us for early design analysis, like Sweep Hints, Find Object, and finally, we had a small example of the interactive and traversal analysis with Tcl commands and GUI. This concludes this video. Again, we are Caro and Rosa. Thank you and have a good day.